Okay, so today we are going to, as discussed, we are going to start some new concepts. Okay, so in that, the first thing we are going to understand is sampling distributions, guys. Second thing, we are going to understand what is a point estimate. And finally, we are going to see the very important theorem called as central limit theorem. Okay, so fine, guys, let's start. Okay, see, first of all, we need to understand, go back to the concept of population and sample. Agree? So we population and sample. So I remember we have discussed this concept in our initial classes of statistics. Agree? So what's the concept over here? So the whole data is called population. Okay, and a subset of this will be called as a sample. Agree? Subset of this will be called as a sample. Fine. So now there are few important concepts or few important challenges we are facing over here, because uh, every time it is not possible or feasible to have the whole population data available. Agree? So even though we want to conduct the or to find out the all the statistical measures, mean, median, etc. on that overall population, but most of the time it might not be possible to have the whole data available. Agree? So that's why we will take a subset of this. Okay, we'll take a subset of this called as a sample. Fine. And now we are going to see, how does this sample will represent the, okay, how does this sample will represent the whole population. Getting? So let's try to understand those concepts and again come back here. Okay. So yes, as I said, this will be a new concepts. Okay. So, but very interesting concepts. Fine. So make sure you are getting the concepts. Fine. So if you see, statistical reference is a process of analyzing sample data to gain insight into the population from which data was collected and investigate different between data samples. Okay. So in data analysis, we often interested in the characteristics of some large population, but collecting data on the entire population might not be feasible. For example, leading to US presidential elections, it would be very helpful to know the political leanings of every single eligible voter, but surveying every voter is not feasible. So instead, we could poll some subset of the population, such as 1,000 registered voters, and use the data to make inferences about the population as a whole. See, guys, what it is saying here is, in statistics, obviously, we are interested to collect the whole population. Okay, but many a times collecting the whole population it may not be feasible. Okay, here we are taking an example of a US presidential elections. Okay, where let's say you are having how many? Let's say you are having like 10 crores people. Okay, 10 crore people are staying in US, and before the elections, you want to survey them and find out the opinion of each and every person. Okay, each and every person. Fine. But the problem here is it is not possible, right, to survey 10 crore people. So instead of that, we are going to take subset of the population, like 1,000 registered voters, and we are trying to make the inferences from this sample. Okay, so that this will represent the population as a whole. Okay, so that is a concept over here. So, but now again, we are going to see this. We are saying I'm taking sample from the population. So how will this sample is representing this population? Okay, how will this sample is representing this population? What is the point of taking this sample, guys? What is the point of taking this sample? Because I cannot access this whole data. I am taking some data and I am, okay, assuming that this will represent this. Okay, wherever I want to use this population, I will use this sample. Okay, so before doing that, uh I should verify whether this is a perfect representation of this or not. Okay, so we will see that with an example, you will get an idea. Okay, so as of now, okay, just try to understand that population sample. Okay, these two concepts, these are clear, right? So slowly we'll start building on top of this. Okay, so now here there is an actually very important point called as a point estimate, guys. So now what is point estimate? See, now you are saying there is a population. Okay, I'm just giving you a basic idea. This is a population. This is now instead of this population, I am using some other thing called a sample. Okay. Now point estimates are those things. Okay, this is a one single point estimate. That means what? Let's say this population is having some mean. Okay, I don't know, because why I don't know? Because this population overall data is not available with me. Okay, because if the whole data is available with me, I will calculate the whole mean of population, but I don't know the whole population of this whole data. Okay, but I'm taking a sample of this population, and now what I'm doing, if I'm calculating a mean of this sample, fine. This is mean of what? This is sample mean. Okay, this is sample mean. Agree? Now this sample mean will act as an representation of this population mean. Getting? Because I am trying to represent this sample, okay, with population. So the sample mean will be representing the population mean. So this sample mean will be also called as a point estimate, because it is one single point which we are estimating it to be the population parameter. Are you getting, guys?
Yeah, Santosh. Just instead of taking population mean and all, we are taking a sample mean, and that is indicating, I mean, instead of population.
Correct. So like that, any point estimates you can take. So let's say you are taking sample variance you are taking. Okay. So now this sample variance will be a point estimate for the population variance. Agree? So these are one single points from the sample which we assume that it will represent the population, because working with population is not 100% possible. What is actual population in any data? If you take in the real life, the whole data across the complete globe will be the population. If you want to calculate height, the complete height of every individual available on this planet is population of height. That is not possible to practically to take. So then obviously, if you observe and think over it, so most of the time we are forced to work on samples. Okay, nobody is going to collect the whole data, population data. So we are, and also it's not practically helpful. Like we cannot spend so much of time. With the time our effort increases, with effort our resources increases, computing power increases, so many things increases. Okay, so but the to alternate better alternative way over here is to work on the samples. But now our job is to make sure how well this sample is representing this population. That means if our mean, okay, if our mean which we are getting from this sample, okay, this should be similar to this population mean. Only then we can say, okay, it will not be exactly same, obviously, correct, but at least the difference should be less. Then we can say, okay, this mean is acting like a point estimate of population mean. Okay. Similarly, you can also have, let's say, standard deviation of sample. Okay, standard deviation of sample. So that will act as what? It is a estimation. Okay, sample itself is estimation, right, guys? Sample is not the exact population. Sample itself is an estimation of the overall data. Okay, because we cannot work on population, we are working on the sample. So sample, in other words, itself is estimation. And now inside that, the parameters are also an estimation. Okay, so a standard deviation of the sample is a point estimate. All these are point estimates, but this standard deviation is a point estimate of population standard deviation. Sample standard deviation is a point estimation of population standard deviation. Getting, guys? Meghna, Sirusha, is this concept clear? Point estimate.
Yes, okay. So,
Okay.
Something I have doubt.
Uh,
So in general, we'll have data sets, right?
mhm.
So huge data sets or whatever data sets. So how we will know when we have to consider the sample and when we have to go with that entire data set as a population? Like every time we'll go with the sample,
No, it
whether we are
depends upon the data. Let's say you are working on small data sets. The whole data you will take. Okay. But if the data is huge, okay. See, because now we are working with small data sets, iris data set, right? And those are small data sets. Okay. So obviously you can use the whole data. But if you're working on some real data sets, okay, see, if you try to understand, even iris data set, what we have considered, that is also a sample in another way, because the actual iris data set will be what? Considering each and every iris flower on the planet will be the overall iris dataset population. Agree?
Okay.
Right? But obviously we cannot collect that. So whatever we work is directly or indirectly is a sample. Okay? And also sometimes you will be needing to work on extremely large data sets. Okay? So real data sets. So there you can trim certain part of the data and work on the sample. Okay, so fine. So I hope that point estimate concept is clear. Okay, so now we'll see. The point estimates are estimation of the population parameters based on sample data, guys. Okay, so here each and every line is actually very important. So that's why be extremely focused, because based upon these only, there are all the like upcoming concepts will be based upon. So as I said, till here, till discrete distributions, whatever we have learned, right? So that is one level. Okay, so till quantiles, percentiles, it was first level. From probability distributions, we have seen a lot of things, and till discrete distributions, it was second level. Okay, but from today, the point estimates, it will be at third level. Okay, so let's have basics very perfect. Okay, so point estimates are estimates of population parameters based on sample data. Okay, for instance, if we wanted to know the average age of registered voters in the US, we could take a survey of registered voters and then use the average age of the respondents as a point estimate of the average age of the population as a whole. The average of the sample is known as a sample mean. Okay, see what it is saying. If you want to know the average age of registered voters, okay, so obviously you cannot go for the entire population. So you can take a survey. That means survey means what? It will get a sample of the registered voters and use that average as a point estimate of the population average. Okay. This average of sample is a sample mean. Okay. Same concept. Overall population, age. Okay. You cannot take the overall mean. So from this, you will take a sample. Okay. This is a sample. And this sample average you will calculate. That means mean. Okay. So this mean, okay, is the point estimate of the population mean. So now sample mean acting as a point estimate of population mean. Okay, fine. So now we'll see an example of sample. See, this is important. Sample mean is usually not exactly same as population mean. Obviously, right? If population is like in 1 CR, sample will be how much, guys? We'll take small samples. Okay, 1000. Okay. So whatever we are calculating on 1 CR will not be exactly same as 1000, right? It will be different, but the difference should not be more. That is the point. Okay. So sample mean is usually not exactly the same as a population mean. Okay. This difference can be caused by many factors, including poor survey design, biased sampling methods, and the randomness inherent to drawing a sample from a population. Okay. So because of multiple reasons, you might get a poor sample. Okay. Let's investigate some point estimates and you will understand. Okay. See, now, see, these are simple imports. Okay. So now what we are doing, see, from the we are creating a data. Okay, so we are creating a distribution, Poisson distribution. Okay, so yesterday we have seen, right? So the last concept yesterday we were seeing, I think, was Poisson distribution. Okay, so where what was the point over here, guys? If you try to recollect, the point over here was just to give you an, yeah. So distribution, the number of events occurring in a time period given the average number of events. That means if you have an average value of particular time period, based upon that, we can try to find out the other number, like another time of period number of events. Okay. Do you remember Poisson? Yesterday we were discussing, right? Certain car wash, if at all the average is 3, based upon this you can also find out what is the probability to get like 6 visitors or 2 visitors, 1 visitors. Okay, based on some average value.
Yes, Santosh.
Okay, so now similarly, so we are trying to create, okay, we are creating a Poisson distribution. Okay, stats.poisson.rbs, this will create a Poisson distribution. And see, over here mean is the 35. Okay, and size is 1,50,000 sample points we are taking. Okay, and this is just a shift, guys. Okay, I'll show you what is a shift over here. Okay, so now if you see, we are taking one more population, okay, of ages, and this is also Poisson distribution we are creating with the mean of 10, and here we are taking size of 1 lakh. Okay, and now what we are doing, now the population 1 is over, population 2 is over. Now we are concatenating these two. That means summing up those two, summing up, not actual summing, but putting together both of those. Okay, that means concatenation. And now we should do the overall age. The age mean is 43.00. Okay, so we have created two set of ages. Okay, and the overall population mean age is 43. Okay, so now what is this LOC? Okay, LOC is called a shift actually. Okay, so if you see the okay, see, for example, if I show you, see, if I take 18. Okay, so what is my if I take LOC is 18, that LOC is for location. That means how much, where you want the mean. For example, if you're taking 18, you're having 43, right? So if I now decrease this to 8, okay, decrease this to 8, okay, so it will become 33. Okay, 10, I have shifted it to 10 minus, okay, if 18 is 43, so if I shift to 8, okay, it will decrease, it will come to 33. If I go to 28, okay, it will go to 53. Okay, like that. So if I go to 28, it will be 53. Getting it just on the mean, okay? The mean, okay? If it is like 43, how where you want if me is 43 mean is okay, it's fine. But if you want to shift the whole graph, okay, 10 parameters over here. So if you want 53, okay, you can give here 28. Fine. So it will shift here. And again, the whole graph will shift here. So now the graph will be over here. Okay. Similarly, if you give some, let's say 38, okay, so it will be 63. Okay, it's just the shift parameter. Okay, LOC is location, the shifting parameter, the shift in the graph. Okay, but the graph will remain the same. Okay, so it's not that important parameter, but I just wanted to show you. Okay, fine. So now I have considered this. Okay, so I have created to see, observe this example very careful. I have created two different set of ages. Okay, and I have concatenated those two, and you got the mean. Agree? Are we good till this point, guys? I would like to go this step by step so that it should be clear. Okay, can everybody give me the confirmation? Are we good till this point?
Yes, sir.
Okay, so now next what we are going to do here is, see, from this population ages, okay, from this population ages, I am randomly taking, okay, I'm randomly taking 500 samples, okay, randomly taking 500 samples. Fine. Overall population is how much, guys? 1,50,000 plus 1 lakh. How much it is? 2.5 lakh.
Yes.
Yeah. So overall population is, observe here, overall population is 2.5 lakh. Okay. I don't want to know what the overall population. Okay. I want to work on sample. So over here, what I'm doing, np.random.choice. Okay. Random module, you remember? So over there in NumPy, we are taking np.random.choice. Okay. From this population ages, A equal to population, take sample of 500. Okay, 500 sample I'm taking. Okay, now my sample ages is randomly it will take. That's why it's random. Okay, overall this population. Okay, see, if I just show you the population ages. Okay, so these are the data, guys. The population ages will be like this. Okay, like this. How many it will be? 2.5 lakh. Okay, like this, you will have 2.5 lakh values. Okay, what are all these? These are all ages. Okay, these are all ages of people. Fine. So like this 2.5 lakh are present in the population. Okay. In that I am taking, okay, in that I am taking only 500 samples. Okay. Randomly it will take some random 500 samples it will take. Agree? Over here you are taking sample ages, and now the sample ages will have 500 values from the population. And once you find out the sample ages dot mean, okay, so 42 is the sample ages mean. Okay. Now actual population age is 43.002372. Now sample is 42.38. What is the difference, guys? 0.6. Almost very close, not even 1. Agree? So it is logical now to say that sample mean, which is this, can act as a point estimate for the population mean, which is this. Okay? Because the values are almost same. Fine. So this is the point estimate. So now point estimate is acting as a representation of the overall value. Okay. So now like that you can have sample mean, like you can have sample variance will be a point estimate. Okay, for population variance. Okay, like that. But as you can see, I have considered only 500 samples. Okay, you can take like 1,000 samples. Okay, as you take more number of samples, right? As you take more number of samples, it will have a better mean, will be more nearer to the population. Okay, is the example clear, guys?
Yeah, Santosh, clear. And what about that random dot seed of 6, Santosh? I have forgotten. Can you please?
Okay. See guys, I'm just showing you. So when I take just 500 samples, see 500 samples if I take, okay. Now what is my mean? I'm getting mean as 42.388. Okay. And now if I take 1000, 42.665. Okay, the difference is decreasing. You see, earlier what was the difference between population mean and sample mean? The difference is 0.6. Okay. Now if I'm taking more samples, okay, if you take more samples, obviously it will have better estimation. Okay. So now the difference is decreasing. Observing 0.33. Now if I take more samples, 2000, the difference is still decreasing. 0.17 it became. Getting? And see, when I take 3000, it is almost 0.003. Okay. If I take 5000, see 0.15, 42.847. Okay. 0.1, 42.8. Like that. Okay. So better take something around like 500 or 1000 samples. Okay. Yeah, I'll come to that, Karthik. But are you able to understand the population estimate, point estimate,
Yeah,
guys?
yeah, it's clear. I'm just asking. That is generator. I mean, it's for to initialize that random values. We'll use that, right?
No, no, no,
Random.
no, no, no.
Mm.
See,
Oh,
the simple concept of input.random.seed here is, see, what when you are taking random, actually this seed will require some explanation. But however, see, since you asked, I'll tell you. See, guys, everybody, I am saying np.random.choice to take random values. Okay. Now, when I say 500 means what? From this overall 2.5 lakh, okay, overall 2.5 lakh, it will take 500 random values. Agree?
yes.
500 random values. Now, the problem here is, if you are running this in your system, if you use the same code, okay, let's say you did not use this. Okay. If you use this code, obviously it will take 500 random. And if I use on my system, it will also take 500 random. So, but my random will be different from your random. Agree?
Correct. Each and every time it will change. Yeah.
Every time it will change, right? So your mean will be different from my mean. Agree? For example, I'll show you now only. See here. So I'm taking this. Okay. So without any seed value, okay, without any seed value, if I'm running this, okay, I'm just running this. Okay. What I got 42, and also let me print the sample also. Okay. I'll print the sample ages also. Okay. See here, guys. What I got 4330. Okay. Starting 4330 something. And the mean is 42.54. Okay. And 0.46. Okay. Now I'm running again. See, did it change the values? Can you
Yes.
observe? See, I'll run multiple times. Can you see the values are getting changed? Agree? So that means what? But every time it will take 500. From this 2.5 lakh, every time it is going to take 500. But that 500 will be randomly, it will take 500. Okay. To avoid that, what we are going to do here is we will say we'll fix it to some seed number. Okay, so now if I say input random dot seed of 6, any number you can take. That is the importance of seed. Okay, so over here, any number you can take. For example, you are taking 6. What value you are going to get? 23, 53, 52. Okay, just starting 3 numbers you observe. 23, 53, 52. Okay, now as long as I use this seed, anywhere you run this code, you will get the same set of values. Okay, see, I'm running it again. What I got? Same. Running it again. What I got? Again. Same numbers. They're not changing. Can you observe?
Yeah, Santosh.
Okay. So now if I ask you, hey Karthik, I'm running with random seed 6, you also use that. So if you use 6, if I also use 6, our results will be exactly the same. Otherwise, what will happen? You will use random, we'll use the same code, but my random set of 500 values will be different from your random set of 500 values. So obviously there will be small minute change, might not be great change, okay, but the difference will be there. Okay, to have the exact values, we are fixing it to some seed value. Okay. Now, if we whenever you use, see, for example, you remember this. What is this? 23. Okay, let me only first row I am copying. Okay, I'm just putting it over here. Okay, for your example. Now I'm commenting this 6. Okay, observe guys. I'm commenting this 6. Fine. Now I'm running it. Okay, I got some other value. Again, I'm running some other value, some other value. Agree? Now I'm again activating this line. Now if I run this, see exactly whatever the value, the first row, the whole data set will be the same, 23, 53, same thing. Okay. Similarly, okay, see, for this is for 6. Okay. Similarly, if you can take any value. See, the one point you should, people usually where they get confused is, don't think there is any relationship between this number and the numbers that are getting generated. Okay, the only relation is whenever you give 6, okay, it will give a set of random number. But the point here is there is mathematically there is no relationship, guys. Okay, don't think because of this 6, this 23, 53, due to some calculation they're getting generated. No, any number you take here or randomly, okay, there will be a fixed set of numbers for those, and that is random. Okay, there is no logic, but the set of numbers will be fixed every single time you give a certain number, the same set of numbers will appear over here. Okay, but this number is just a random number. Okay, for example, if you give 0, a particular set of number will appear. Okay, are you guys getting? See,
Yeah, Santosh,
I'll
clear.
give 0. Okay, for example, I'll give 0. Okay, see, for 0, what I got, this is the number. Okay, see, let me write it over here. Okay, 0. Okay, these are the number. Fine. And some any number you can take here in random, right? Any number you can take. Okay, so 1561 I'm taking. Okay, see, I got some other number. Okay, so now what I'm trying to say over here is there is no logic why these numbers are getting generated when I give 1561. Why these numbers are getting generated when I give 0. There is no logic. But we are not concerned about the logic. The only concept over here is it is 100% sure that whenever you give 0, you will get exactly this set of numbers every time. Whenever you give 1561, you are going to get exactly this set of numbers every time. Okay. For example, you see, now I am removing this. Okay. I'm commenting this. I'm running. Okay. It's completely new set of numbers are getting generated. Can you see? But now see, when I give 0, okay, when I give 0 and run this, see guys, what I got? Same number 25, 50, 25, 55, 20, 50, 25, 55. Agree? Are you guys understanding?
Yeah, Santosh.
Yes, sir.
Okay. So now if you see, I'm giving 1561. Okay. See, exactly 62, 54, 48, 62, 50, 25, 48. Same numbers you will get. Similarly, if I give 6, same 23, 53, 52, 23, 52, 52, 24. Same number. So that means for every random number, see, I'm repeating, for every random number you take, any number you take, a specific set of values will be generated. Okay. But there is no understandable logic why only this set is getting generated for this number. Okay, it is just a random set of number and it is assigning some number, a random number for that set. Okay, but the importance over here is every time you give that number, same set will get generated. Okay, so to get comparable results across different systems. Okay, so we will fix a random seed. Okay, not even systems also, because now only, okay, now only I am running this. Okay, I'm running this notebook. Okay, over here I'm running. After 10 steps, okay, after running 10 steps below this, okay, I understand. Okay, I did a mistake. I'll come back. Okay, I'll correct something, and if I run this now again, it will give me a new set of random values. My calculations will be changed, right? So every time in my notebook only, if I start running this 10 times, 10 times it will generate 10 random values. So it will 10 random values of sample mean will be created. Obviously, this difference will be changed 10 times. Fine. So there is no consistency. Agree? So to avoid that, we actually fix it to some random seed value. Okay. So once we fix it to some random seed value, every time you give that value, it will give the same number. Okay. Sirisha, is that clear? Sirisha? No, Sirisha, can you tell me like why we are using random seed? Hmm? Okay. See, okay, fine guys. I hope that's clear. So now coming back to the actual concept, see, we have considered 500 samples and we got the sample age, and the difference is very, very minute. Okay, so we can say that sample mean, okay, the sample mean is acting like as a point estimate of the population mean. Okay, so fine. Now the next concept over here is, okay, see, our point estimate, okay, to get same set of values every time. Yeah, correct, Suresh. Okay, fine. See, our point estimate based on a sample of 500 individual underestimates the true population mean by 0.6 years. Okay, this is less than our sample mean is less than population mean by 0.6 years. Okay, because this is age. Okay, now, yeah, but it is close. This illustrates, okay, this illustrates the point. We can get a fairly accurate estimate of a large population by sampling a relatively small subset of individuals. Okay, that means even though the overall population is 2.5 lakh, but we have considered just 500 samples, and if you are calculating the mean, that mean is not very different. It is just 0.6. It's very, very close, which means we can get a fairly accurate estimate of large population by sampling a small subset of individuals. Okay, even if you have small subset of individuals, still you can get a large population estimate. Okay, now another point estimate that may be interest is the proportion. Okay, we have seen mean estimate, right? So now we are going to see a proportion estimate, guys. Okay, so now let's see now, see here what we are trying to do. See again, random seed dot 10. Okay, now I think random is clear, right? So when we are, because every time we are using the random module. Okay, see, when we will use this random seed, guys, when you are using the random module. Why? Because random module will create values randomly. Okay, that's why, to have some consistency between every run. Okay, because we are generating 1,000 random samples. Okay, so we will fix it to some random seed value. Okay, fine. So now we are having what we are doing over here. So we are taking the white. Okay, so here we are different races we are considering over here example. So to know the race of each voter we poll, okay, we get a sense of all the overall demographic of the voter base. Okay, so now so in US there are like different races, right? White people, black people, Hispanic, Asian, and other people. Okay, so now in the white people we are taking 1 lakh people. Okay, white into 1 lakh. Okay, and black into 50,000, Hispanic into 50,000, Asian into 25,000, and other into 25,000. Fine. So we are adding all those. That means what? We are creating a list. Okay. What is list? List of, are you getting? So if I say hello into 3, what it will print, guys? 3 times hello. Hello, hello, hello. Like that, white into 1 lakh. 1 lakh white people, 50,000 black people, 50,000 Hispanic people, 25,000 Asian, 25,000 other. Okay, so like that overall how much guys? 1 lakh, 50, 52 lakh, 15, 50. Again 2.5 lakh. Okay, above population only, but these are with the races. Is this clear? Population races part?
Yes, sir.
Okay, so like that. So inside this, what you will have? Okay, inside this you will have, see, can you see white? You will have 1 lakh white, and okay. So if you take the last some 1 lakh, so if I take, sorry, after 2 lakh, if you start taking, you will have Asian, okay, like that. Okay, so these are the values present inside this population traces. Okay, from here, this is population, guys. Okay, this is population. From here, what we are doing, random dot sample. That means randomly taking a sample from this population traces. Okay, 1,000 samples I'm taking. That's all. Okay, from 2.5 lakh, take 1K samples. Okay, fine. Now that is a demo sample. Now for race in set of demo sample, okay, for race in set of demo sample, now race plus proportion estimate. Okay, this is just for printing, but the main thing what we are doing, we are trying to take the proportion. Okay, proportion is what? How many values of white are present by overall count. That's it. Okay, now here demo sample dot count of race by 1,000. Okay, see, proportion is in the population, how many white people are there by total count. Similarly, how many black people are there by total count. How many Hispanic people are there by total count. That is a proportion. Similarly, here what we did from this population races, we just took 1,000 samples. Okay, demo sample. 1,000 samples means what? Roughly 1,000 we took. It could be it will have different proportions. Some white, some black. Okay, different combinations will be present in this demo sample. Okay, so if I show you the demo sample, see, black, white, Hispanic, able to see? Like this, you will have 1,000 values inside the demo sample. Okay, because you are taking 1,000. Fine. So now what we are doing here is, you are taking set of demo sample. Set of demo sample means you will get unique value. Okay, you will get unique value. Set of demo sample means what? So yeah, demo sample is this, but if you take the set, so you will have just the unique values of this list. That means you will have only this 5, because these are the 5 created. Okay, so these 5, okay, you are taking and you are looping for race in set of demo. That means every time you are taking one value, okay, and you are just printing race plus proportion estimate. But how the proportion estimate is demo sample dot count of race by 1,000. Okay, that means what? Just like how you are saying in population, see, it's very simple. Okay, here in population, okay, here is sample. Okay, for example, white population is white count by total count in population. Similarly, white count in sample by total count in sample. That's it. That's what we are saying. See, demo sample dot count of race. First time it will take, race is what first time it will take, let's say Asian. Okay. Now once it takes Asian, okay. So then, see, I'll run this once so that, okay.
So Santosh, like total, how many whites are present out of 1,000 members?
Yeah,
Uh,
yeah,
that
correct.
only, right? Yeah.
Correct. Correct.
Yes.
So demo sample dot count of race means, first of all, let's say it is taking white. Okay. So this white, how many whites are present inside this demo by total count is 1,000 samples. Okay. That is a white proportion, sample proportion. Similarly, next it is taking Hispanic. Okay. That means demo sample, that means demo sample dot count of Hispanic. That means how many Hispanic are present in the demo sample by 1,000. That means Hispanic proportion. Okay. And population Hispanic is how much? Population Hispanic proportion is, we know 50,000. That means 50,000 by 2.5 lakh. Okay. We directly know. White proportion is how much? 1 lakh. 1 lakh by 2.5 lakh is a white proportion in population. But here we don't know how many randomly it is picking up. Okay. But we'll see the proportion. Okay. But here if you see, see guys, now what is the proportion of white over here? Okay, so these are the proportion given by the sample. Okay, but now what is the proportion of white in the constant? See, white proportion is 1 lakh. Agree? In the population, I'm saying in population, white is 1 lakh. Overall is how much? 2.5 lakh. Agree? So the proportion of white will be 1 lakh by 2.5, 0.4. Agree? This is population. In sample, what is the white proportion estimate? 0.378. Are this close?
Yeah,
Getting?
Santosh. Yes.
Getting how we are calculating this? Simple. In white, how many people are there? Oral count. Similarly, here also, in sample, how many white are there? By its total count, 1000. Fine. Similarly, if you see for black, next it is Hispanic. Okay. So for Hispanic, it is saying 0.192. That means the count is, it is dividing the count of Hispanic by 1000. Okay. Here also Hispanic, how many took? We took 50,000. Okay. So if you take 50,000 by 2.5 lakh, 0.2, which is 0.192. Very, very similar. Getting or not getting?
Yeah, Santosh, clear.
Yes, sir.
Okay. Simple. Here also next it is saying other. Okay. Other, how many are there in population? 25,000. Okay. So if I take 25,000 by overall 2.5 lakh, how much it is? 0.1. Similarly, here also, if you see the other population, okay, same thing it is doing here. Okay. Demo sample dot other, it will take other, that count by its count is 1000, 0.099, almost similar to 0.1. Okay. Almost similar to 0.1. Fine. So now, yeah. And similarly, okay, so if you're getting confused, okay, you can also print the demo sample dot count of race. Okay, after that you can print this. Okay, see, I want to just print this race. Okay, so then I'll print this. See, now it should be clear. Okay, so white in overall population, white is 1 lakh. The overall count is 2.5 lakh. That's why the value is 0.4. Okay, but in demo the count randomly we took 1000, right? In that 1379 are white were there. Okay, so by 1000 is 0.379. Fine, very much clear, near to 0.4. Similarly, Hispanic is 50,000. It is 0.2. Okay, here also Hispanic 192 values of 1000, 0.2, like that. Okay, and for example, Asian, if you take 25,000, okay, it is 0.1. Okay, here also Asian, if you see 90 out of this 1000 values, roughly it took 99 values and it is 0.09. It is very close to 1. Clear? So if you see, instead of even though we don't have this overall 2.5 lakh values, we just took the randomly 1000 values. The proportion of this each and every race when compared to population is very much similar in sample also. Agree? Every proportion. See, white is 0.3 times, Hispanic 0.1. Okay, Asian, black. Okay, if you see the black, okay, black is appeared 50,000 times over here. See, black proportion is how much, guys, in population? 0.2. Here also 0.23. Very similar. Fine. The proportions are very much similar in both of this. Okay, this is one more estimate. This proportion estimate. Okay, so notice that the proportion estimates are very close to the underlying true population proportions. Okay, so now as you can see, this proportion, this is also proportion point estimate. Okay, so anything which will represent the population can be considered as an estimate, point estimate. Okay, so earlier we have seen sample mean estimate. Okay, mean point estimate. Okay, where the sample mean is almost similar as a population mean. Okay, 42.388, 43. And now we are seeing sample proportion estimate. Okay, is it clear, guys? Everybody?
Yeah, Santosh, clear.
Okay, fine. So yeah, so as I said, let's stop it at 7:30. Fine. If that is the case, okay. I'll also join sharp 6:30. Okay, from tomorrow. Fine. So I would say that would be the point estimate and population parameters. Okay. And based upon this only, tomorrow we are going to understand. Okay. So based upon this only, tomorrow we are going to understand. See, I think we have covered the sampling. So we'll see sampling distribution tomorrow. Okay. It is related to sample concept only, but we are going to see again. and sample and population we have seen. Point estimate we have understood. We have seen the examples. Okay, based upon these concepts, we are trying to build the central limit theorem tomorrow. Okay, so once you understand this, then you will understand this in better way. Okay, on this only, again, the related concepts will be coming out from this. Okay, confidence interval, etc., etc. Okay, fine. So I would say that's all from the point estimate and sampling, guys. Okay, so let's meet tomorrow and try to understand central limit theorem, which is one of the most important theorem. Okay, fine, guys. That's all from my end today. Okay, so take tomorrow 6:30 sharp.